Europe's weather is about to change, and for most of the continent, that change means it's about to get hotter, drier, and more dangerous before it gets better. A powerful heat wave is building right now across central and southeastern Europe. PE and multiple independent forecast centers are converging on the same picture. Temperatures running as much as 10 to 12 degrees Celsius above normal for this time of year, arriving on top of a landscape that's already been stressed by drought since spring. So let's get into exactly what's coming, where, when, and how confident we actually should be about each piece of it. Here's where things stand right now. Europe went into this summer already dry. A drought assessment published in late July 2026 described widespread soil moisture depletion across France, Eastern Europe, the Baltic states, and parts of Scandinavia, and that's not a shortfall, a few days. Was always of rain can fix. Soil moisture deficits like this build up over months, and they only reverse with sustained wet weather over a comparable stretch of time, which is exactly what the coming weeks are not forecast to deliver. The wildfires that have already burned across France and other parts of southern and western Europe this summer are a direct symptom of that drought, and they're part of a broader pattern. When the ground is this dry and vegetation this parched, a heat wave that would be serious in any other year becomes measurably worse because there's no moisture buffer left to absorb the additional stress. Evaporation accelerates, rivers drop further, and cities lose whatever cooling effect their parks and green spaces would normally provide once that vegetation dries out too. That's the baseline condition the next several weeks are arriving into. Now let's talk about the mechanism actually driving this. Forecasters are describing the atmospheric setup taking shape as a blocked high-pressure pattern, specifically resembling what's called an omega block, a configuration where a strong area of high pressure sits anchored over the core of Europe, with deep, low-pressure systems positioned out to the west over the North Atlantic and to the east over Russia. When you look at the pressure pattern on a map during one of these events, the shape genuinely resembles the Greek letter omega, which is where the name comes from. High pressure is what drives heat waves in general. It suppresses cloudy formation, blocks rain-bearing weather systems from moving through, and lets the sun bake the same patch of ground day after day without interruption. What makes an omega block specifically dangerous is persistence. Once one of these locks in, weather systems get shunted around its edges instead of passing through, and the high just sits there, baking whatever's underneath it for as long as the block holds together. That's the structural reason this event is being described as a sustained multi-week pattern rather than a short, sharp spike that breaks after a day or two. Multiple major forecasting centers, the European Center for Medium-Range Weather Forecasts, the U.S. Climate Forecast System, and independent severe weather forecasting groups have been tracking this block develop and strengthen over recent weeks, and their confidence in the core features of the event, its rough timing, its geographic footprint, and its intensity in the most affected zone, has been increasing rather than decreasing as newer model runs come in. That's a meaningful signal in forecasting terms. When independent models converge and stay converged as the event gets closer, that's usually a sign the underlying pattern is genuinely locked in, rather than an artifact of one model's noise. So where is the heat actually concentrating? The broad hot zone runs in an arc from the Iberian Peninsula through France into Central Europe, then sweeping down through the Balkans into southeastern Europe. An enormous footprint covering dozens of countries and hundreds of millions of people. Interior Portugal and central Spain are looking at temperatures running around 6 degrees or more above normal for early August, which is notable given that this region is already one of the hottest parts of Europe at this time of year, even under ordinary conditions. Parts of France, already dealing with active wildfires this summer, could see anomalies of 7 degrees or more during the peak of the event, which compounds fire risk across vegetation that's been drying out for weeks. Northern Italy is positioned for anomalies in the range of 4 to 5 degrees above average, which is enough to put real strain on public health systems, power grids, and water infrastructure simultaneously, especially in a region already dealing with reduced river flow. But the zone drawing the most concentrated attention from forecasters, the one where multiple model systems are converging most tightly, runs through Central Europe specifically: Slovakia, the Czech Republic, Austria, Hungary, Serbia, Romania, and the surrounding countries. Current forecasts point to anomalies of 10 to 12 degrees Celsius above the seasonal average in this pocket during the most intense phase, expected to build through the first week of the period, and potentially intensify further into the second week before the core of the heat begins drifting eastward. When a region that's already hot at this point in summer runs 10 or 12 degrees above its normal peak, you are looking at daytime highs pushing deep into the 40s Celsius across parts of this zone, with some forecast runs suggesting the potential to challenge or break national temperature records in countries that have already set new benchmarks repeatedly over recent summers. It's worth putting a specific historical marker next to that, so the scale makes sense. The 2024 European heat event, one of the more severe on record, produced temperatures as high as 46.8 degrees Celsius in Cyprus and was linked to more than 62,000 heat-related deaths across the continent, based on research published in, along the way, the journal Nature Medicine. Current forecasts for this event do not point to exceeding that scale across the continent as a whole, but for the specific zone of Central and Southeastern Europe, the combination of extreme anomalies, a deep pre-existing drought, and a landscape already stressed by earlier heat events from May and June means the actual health and safety risk in that pocket is elevated well beyond what the raw anomaly number alone might suggest to someone unfamiliar with how these compounding factors work together. Independent severe weather analysts tracking this pattern in real time have described the thermal anomalies in some upper air measurements as tracking into the 99th percentile historically, the kind of statistical outlier that indicates a potentially historic event for the specific regions affected, even if it doesn't match the continent-wide scale of 2024. Their analysis points to temperatures surging past 40 degrees Celsius widely across the Iberian Peninsula and France during the initial peak, with the core of the pattern then drifting eastward and dragging intense heat into Western Germany, the Benelux countries, Italy, Hungary, and much of the northern Balkans over the following days. The source of the heat itself is straightforward, a mass of hot, dry air originating over North Africa and the Sahara being pumped directly northward into the continental interior. That's the same basic mechanism behind the worst European heat events of the past decade. It isn't new or exotic. What's different this time is the blocking pattern holding it in place rather than allowing the usual Atlantic weather systems to flush it back out. That persistence is the actual story here more than the heat source itself. Now, it's important to be clear that this isn't a uniform continental event, because forecasts that paint the whole of Europe with one brush end up misleading the people who live in the areas that don't fit the main pattern. Norway is expected to run below average for temperature in the earlier part of this period, with more active rainfall along parts of its coast, a genuine welcome contrast to the rest of the continent. Sweden and Finland are expected to sit close to average, without the extreme anomalies further south. Scotland looks likely to run several degrees below average during the first week, while England, on the same island, could simultaneously sit a couple of degrees above. A sharp divide that reflects how differently the jet stream and Atlantic weather systems can behave over relatively short distances during a continental scale blocking event. Greece, Albania, and Turkey sit closer to seasonal averages for both temperature and rainfall, positioned at the margins of the main heat core rather than underneath it. So where YU actually are in Europe meaningfully changes what this event looks like for you, and it's worth checking your own National Meteorological Service rather than assuming the headline anomaly applies uniformly. On the rainfall side, the picture is genuinely concerning almost everywhere the heat is concentrated. Precipitation outlooks show significant deficits, well below normal totals, across most of the same areas already drought-stressed from spring and early summer. Some of the specific numbers being projected are stark. Parts of the Alps and adjacent areas could run 100 millimeters or more below their typical rainfall total for the period, which is an enormous single-month shortfall. Northern Italy, along with areas extending into Croatia, Montenegro, Bosnia, and North Macedonia, are similarly positioned for well below normal rainfall. These dry zones aren't just holding their current deficit steady. They're expanding it week by week because the heat itself accelerates the drying process, with higher temperatures driving faster evaporation from soil and vegetation that's already running low on moisture. The exceptions, where above AV, average rainfall is genuinely possible, are narrow. Coastal Norway, Ireland has a reasonable shot at some above-average precipitation, and parts of Sweden and Finland may see more active weather systems moving through. But for most of the continent, this period does not look like the stretch that breaks the drought. The consequences of extreme heat sitting directly on top of an already deep drought go well beyond discomfort. Wildfire risk, already serious across France and other parts of southern Europe this summer, faces significant additional cases. Reassured from these conditions, drought analysis from independent climate monitoring groups has been explicit that a major drought is unfolding as meteorological summer fades, with heat and dryness spreading eastward through the period. When vegetation is this moisture-stressed, F-ire weather conditions can develop rapidly even in areas not traditionally considered high risk, which is exactly what's already played out in France this summer. Agricultural impacts are a serious parallel concern. Rivers and reservoirs already running low from the dry spring, and early summer phase continued stress with real implications for irrigation, hydroelectric generation, and general water supply that will compound rather than ease as the dry stretch extends. River systems like the Rhine, the Danube, and Po tributaries are already running significantly below seasonal norms in some areas, and continued heat and drought through this period could push some of those levels to points where industrial cooling water withdrawals, shipping, and hydroelectric output all face constraints at the same time. It's worth spending a moment on power infrastructure specifically, because extreme heat events like this one create a compounding problem for electricity grids that's easy to overlook. Air conditioning demand spikes exactly when heat is most extreme, pushing electricity consumption toward or past season. Owl peaks. At the same time, the generation side of the grid gets squeezed from two directions. Thermal power plants, including nuclear facilities, often rely on river water for cooling, and when river levels and flow rates drop during a drought like the one currently affecting the Rhine, Danube, and Po systems, some plants have to reduce output, or in more severe cases, temporarily curtail generation to avoid discharging water back into rivers at temperatures that would harm aquatic ecosystems. Hydroelectric generation, which several Central European countries rely on for a meaningful share of their electricity, also suffers directly from reduced river flow and lower reservoir levels. So the same drought driving the wildfire and agricultural concerns described above is simultaneously constraining the supply side of the grid at precisely the moment demand is peaking. That combinatio N has caused real operational strain in past severe European heat events, and it's a genuine risk factor worth watching in the affected countries, this time as well, alongside the more commonly discussed public health angle. There's also a transportation and logistics dimension worth understanding. Extreme heat can force speed restrictions on rail lines in some countries because tracks can expand and warp under prolonged high temperatures, particularly on older infrastructure. River shipping, already constrained, by low water levels from the drought, can face further restrictions or reduced cargo loads if levels drop further during the heat event, since barges need a minimum depth to operate safely and efficiently. None of this is unique to this particular event. These are well documented. Now, let's talk about the broader driver sitting underneath all of this, because it matters for how long this pattern is likely to last. El Niño. The El Niño Southern Oscillation, or ENSO, is the natural warm and cool cycle in Pacific Ocean temperatures that shifts global weather patterns every few years. As of this summer, no AA's climate. Prediction Center has confirmed El Niño conditions are already present, not just forecast. The agency upgraded its alert status to an El Niño advisory back in June, and the probability of El Niño persisting through the coming winter sits above 95%, with a meaningfully high chance it strengthens into what's classified as a very strong or super event by later in the year. That's a real, current, verified status, not speculation. It's worth being precise about what that actually means for Europe specifically, because El Niño's effects are complex, and over Europe in particular, notably less direct and less dramatic than its effects elsewhere in the world, like the tropical Pacific or the Atlantic hurricane season. During the warm season, El Niño tends to reinforce the kind of high-pressure blocking patterns and prolonged heat Europe has already been experiencing this summer, rather than single-handedly causing them. Think of El Niño less as the direct cause of this specific heat wavy. He and more as a background amplifier that makes blocking patterns like this one somewhat more likely and somewhat more persistent than they'd otherwise be. The World Meteorological Organization's outlook through the early autumn N shows above normal sea surface temperatures remaining firmly in place in the relevant ocean regions, which supports continued warmth over the continent into the early autumn months, though that's a probabilistic outlook, not a locked-in certainty, and it should be read with that caveat attached. Looking specifically at how this event is expected to evolve week by week. The first week of this stretch is expected to bring continued hot, dry conditions, with the heat core extending eastward toward the western Black Sea region. The following week sees that eastward expansion continue, with the most extreme heat pushing further into Eastern Europe and the Black Sea coastline, while patchy, unreliable rainfall attempts to reach some northwestern coastal areas without meaningfully breaking the broader pattern. By the third and fourth weeks, the heat center is projected to shift further toward Eastern Europe and Western Russia, while Portugal and Spain remain hot and dry in the southwest. Germany and Poland may finally see some more meaningful wet weather arrive during this later stretch, offering those countries their first real relief from a dry pattern that's been building since spring. I want to flag something important about forecast confidence here, because it's easy to present a multi-week outlook with uniform certainty when the reality is that confidence actually varies significantly by how far out you're looking. The near-term picture, roughly the first week to 10 days, is well supported by multiple independent CI, converging forecast models, which is why forecasters are speaking about it with real confidence. The picture further out, the back half of the period, and especially anything reaching into September and October, carries meaningfully more uncertainty, Forecast agencies themselves are explicit about this. Longer-range outlooks are probabilistic tendencies, not fixed predictions, and they get revised, sometimes substantially, as the actual weeks arrive. So treat the 10 to 12 degrees above average in Central Europe during the first 2 weeks. Forecast as high confidence, and treat anything about specific conditions in late September or October as a lower confidence tendency that's worth rechecking as it approaches, rather than something to bank on today. There's a longer-term piece of context worth understanding here too, because it explains why events like this are becoming more frequent rather than being purely a one-off. A study published in the Proceedings of the National Academy of Sciences in 2025 found that the kind of atmospheric blocking patterns responsible for these extended heat events have nearly tripled in frequency since the 1950s, linked to changes in the temperature gradient between the tropics and the Arctic, which alters how the jet stream behaves. That's a structural long-term shift, separate from any single season's El Niño status, and it's part of why Europe has now experienced 3 consecutive summers marked by significant heat and droughts. The current El Niño sitting on top of that longer-term trend is best understood as a short-term amplifier, layered on a structural shift that's already been building for decades, 2 separate drivers reinforcing each other in the same direction, which is part of why forecasters are treating this particular season with unusual seriousness. So what does this actually mean if you're in the affected zone practically right now? For anyone in Slovakia, the Czech Republic, Austria, Hungary, Serbia, Romania, and the surrounding countries specifically, where the most extreme anomalies are forecast, the sensible approach is to take this seriously and prepare now rather than waiting until the heat has already arrived. Temperatures running 10 to 12 degrees above seasonal norms in this region create conditions where extreme heat isn't just uncomfortable, it's actively dangerous, and that danger isn't limited to people already in frail health. Outdoor workers in agriculture, construction, and logistics face real heat stress risk during afternoon hours at these kinds of anomalies. Urban areas with large amounts of paved surface and limited green space will retain heat overnight, which prevents the human body from recovering between one day's heat exposure and the next. This is a big part of why prolonged heat waves are so much more dangerous than a GLE, very hot day in isolation. Nighttime temperatures across cities in the affected zone could stay above 20 degrees Celsius throughout the event, a condition public health agencies have specifically flagged as dangerous for elderly residents without air conditioning, which remains considerably less common across much of Central and Eastern Europe than in regions that have historically dealt with more frequent extreme summer heat. Wildfire risk across France, northern Italy, and much of the Balkans is likely to stay elevated and could worsen during this window as the heat accelerates drying in vegetation already close to critical moisture thresholds. It's also worth paying attention to air quality alongside temperature, because the same drought and heat conditions that elevate wildfire risk also tend to elevate ground-level ozone and particulate matter, which can stress the respiratory system even in people who are otherwise healthy. If you want practical steps, rather than just the forecast picture, identify cooling centers in your area if you don't have reliable air conditioning at home. Check in on elderly neighbors, friends, or family who may be more exposed to nighttime heat without cooling. If you work outdoors, it's worth raising the possibility of adjusted hours during the peak of the heat with your employer ahead of time and during the event itself. And keep checking your National Meteorological Service directly as the days go by, since the specific timing and which cities see the worst of it will keep getting refined as the event gets closer. The broad picture described here is well supported across multiple independent forecast systems, but the fine-grained, day-by-day details are still evolving and will keep sharpening as we get closer to the peak. The honest summary is this: a powerful, well-forecast heat wave is building for Central and Southeastern Europe, with the most extreme anomalies expected over Slovakia, Czechia, Austria, Hungary, Serbia, and Romania, layered on top of a drought that's already been intensifying since spring. Western Europe, including Spain, France, and Italy, will also see significant above-average heat, though somewhat less extreme than the Central European core. Drought conditions are expected to expand rather than ease through this stretch. Wildfire risk remains a serious concern from France through the Balkans, and Northern Europe will be relatively more comfortable without being entirely insulated from the rotor pattern. Underneath all of it sits a strengthening El Niño that shows no signs of weakening in the near term, pointing toward continued warmth and its associated risks well into the autumn. Though, again, that longer-range piece carries meaningfully more uncertainty than the immediate 2-week forecast, and is worth rechecking as the season progresses, rather than treating as settled today. One last piece of framing worth leaving you with. It's tempting to hear a forecast like this and file it away as one more entry in an increasingly familiar pattern of another European heat wave. And in one sense, that's fair. This isn't a freak, unprecedented event arriving out of nowhere. But that familiarity is itself part of the story worth taking seriously rather than dismissing. 3 consecutive summers of significant heat and drought isn't a coincidence, and the atmospheric blocking research referenced earlier suggests it isn't likely to be the last one either. The practical upshot is that the response to events like this is shifting in places, from wait and see to expect and prepare, particularly in the Central and Eastern European countries, where air conditioning penetration remains lower, and where this kind of prolonged, elevated nighttime heat is a relatively newer experience for local infrastructure and public health systems to manage compared with regions further south that have dealt with these intensities for longer. If you're trying to track how this actually unfolds day by day, rather than relying on any single forecast snapshot, the most reliable approach is checking your own National Meteorological Service directly, since those agencies have the most localized, most frequently updated data for your specific region, and they'll flag any significant revisions to the outlook as new model runs come in. Independent severe weather forecasting groups and the major international modeling centers mentioned earlier are also useful for the broader continental picture, but local detail, which specific days, which specific cities, how the timing shifts by a DE or I or 2 in either direction, is going to keep sharpening over the coming days, rather than being fully settled right now. The core signal, though, the one multiple independent systems agree on, is clear. Heat, drought, and elevated risk across a large stretch of the continent, concentrated most intensely over Central and Southeastern Europe, arriving on a pattern that shows every sign of holding in place rather than breaking quickly. That's worth taking seriously, and it's worth preparing for now rather than after it arrives.